So what we're basically doing here is the hard part is finding the net work, the net force. Since we know the displacement, we know that net work equals net force times displacement, and we know displacement 3.6. So finding the net force is the tricky part. And I'll draw another diagram. So here's the whatever it is, the cargo canister. And here's the first force, F1. That's a bad force. Let's see. Go away. Here. Cargo canister. And the first force, F1, which is in the x direction, negative x direction. So it would be -3 newtons. And we could say negative because it's in the x direction only. So there's no y force in that first force. So here's the so anyway, so the second force is that way, sort of, and there's an angle between the y-axis and that force, which is 49 degrees. And this second force, F2 equals 3.5 newtons magnitude. And we can find the x component of that force, which is 3.5. We'll call it negative because it's going to be in the negative x direction. So negative 3.5 sine 49 degrees, and that is negative, what is it, negative 2.64 newtons. We'll call that F2x. It's a bad 2. F2x. So we can also find the Fy. So F2y. It's going to be negative because it's in the negative y direction. So negative 3.5 cosine 49 degrees equals negative 2.3 newtons. And then there's this third force with a magnitude of 10 newtons. And breaking it up into its components, the angle between that force 3, and the x-axis is 33 degrees. So F3y is in the positive direction, so it would be positive 10 sine 33 degrees, which equals 5.45 newtons. And I'll write this in another color. So F3x is in the positive x direction, so it would be positive 10 times cosine 33 degrees, and that equals 8.39 newtons. So Now we can find, so we have all the forces broken into their component vectors, and now we can find the net force, new color, net force in its component vector. So we have, this is the greatest force, so it will be 8.39 minus this F1x 3 minus this F2x 2.64, and that's an I in the x direction, and that would be plus 5.45 F3y minus F2y 2.3 newtons, and that's J in the y direction. So this equals 2.75 I plus 3.15 J F net, and we can find the magnitude of this force. So this is the x component, 2.75 newtons, and this is its vertical component, 3.15 newtons, and solving for F net, it would be F net equals square root of 3.15 squared plus 2.75 squared, and that equals 4.18 newtons. So don't forget that we also have to put back this displacement. We have to get the net work. So we have this because it was given, and you can't see it now, but it's 3.6 meters. So work net equals 4.18 times 3.6, and that equals 15.05 joules. And that is the right answer, at least for me, because those are all my values. Yours are all different. So do it with yours. Bye-bye.